improves the optimal performance of cadmium telluride process. Before I start, I would like to provoke a thought to you. We often hear this remark that solar cell companies are going bankrupt. The need for transition to greener energy is on high peak. To tackle all these questions and to tackle all these thoughts, it is very important for us to make a transition to the use of green energy resources. With that thought in mind, we started our EEE400 design project 1 year back, and for our proposed project, we started working with cadmium telluride solar cells in comparison to market dominant or more conventionally present silicon-based thin-film solar cells. Now, we often get this question: why are we proposing the use of cadmium telluride-based thin-film solar cells when there is a commercially available and a more mature technology for silicon-based thin-film solar cells? The answer is, although the silicon-based thin-film solar cells has a more matured market presence, still its payback period is very high, for which it is still not publicly or globally accepted. The reason can be divided into three categories. When we are trying to make it silicon-based thin-film solar cells, the material required is very high, for which the cost of manufacturing is also very high. And when the cost of manufacturing such solar cells are high, it is very difficult for the common people to accept it for using their households or for industrial applications. As a result, we are proposing cadmium telluride thin-film solar cells. Now, cadmium telluride has many advantages over silicon. Its absorption coefficient is almost 10 times for same dimension. Say 1 meter of silicon is equivalent to almost 10. One meter of cadmium telluride is equivalent to 10 meter of silicon. So the dimension is getting reduced, but the functionality or the efficiency is not being compromised. This is one of the prime reasons why we are proposing cadmium telluride-based thin-film solar cells. Moving on to the next slide. These are some of the journals we reviewed for our design project. All of them are Q1 journals. While we are reviewing this journal, we came upon some problems that needed some addressing. The problems are, there is still no detailed study why a solar cell should be globally accepted. To address this issue, we did a temperature study. We conducted a study why a thin-film solar cell should be accepted across the globe in different cities. We tried to do a temperature variation study taking temperature of globally dominant some cities. Next, these are the, after literature review, these are the main problems that were found, and the solution we are proposing is, although silicon-based thin-film solar cell is market dominant and more commercially available, still cadmium telluride-based thin-film solar cell should be accepted as a better substitute. Why? Because it is reducing the material required, for which the manufacturing cost is going down. At the same time, we are not compromising its functionality or efficiency. Moving on. Sorry.
So, our research methodology can be divided into 4 sections. For example, literature review, modeling, simulation, and result analysis. At first, in literature review, first identified what are the limiting factors that are affecting the performance of our cadmium telluride solar cells. Based on that, we also further reviewed the literature to came up with different light trapping technique that can enhance the performance. After that, we defined the simulation parameter from the literature to conduct a simulation in a simulation environment. We have also used instrumentals, editing, and device suite. Later, we conducted our simulation and varied the morphological features of our different nanostructures that we have implemented in our cadmium telluride solar cells. And finally, we came up with different results, and based on the result, we have found the optimal configuration of our nanostructure that gives us the best performance for our cadmium telluride thin-film solar cells. So, as our work is mainly based on simulation,